All right, let's go ahead and take a look at Unit 4, Day 4. We're going to be talking about proving triangles are congruent. Now, there's a lot of different ways we can do this. Okay, but the idea that triangles are congruent comes from the fact that if they're congruent, all their corresponding parts are congruent. All angles are congruent, all sides are congruent. And we talked about this idea of CPCTC. Remember that corresponding parts of congruent triangles are congruent. Okay. Now, you might think that if we wanted to show that two triangles are congruent, I would need to show all their corresponding parts are congruent. And we can do that, and that's using the definition of congruent triangles or using CPCTC. But there are actually some shortcuts we can make, and I'm going to give you some examples of those before we actually take any notes. Okay? So I've got 3 segment lengths here. Okay? 3 segment lengths. This isn't not anything you have to copy down. You just have to watch this part. Okay? With these 3 segment lengths, I can make a triangle. Okay? And the idea is that with those segment lengths, any triangle with those same lengths would have to be the same exact triangle as this. So if I took a side that was congruent to this side, and one congruent to this side, and this side, I get the same triangle. Okay, so even without knowing the angle measures, we know that these 2 triangles are exactly the same. Okay, they're the exact same triangle. And I haven't mentioned any of the angle measures. We don't get any different angle measures just because I turn it around. Okay, it's kind of falling apart on me, but you get the idea that if I can show there are 3 pairs of congruent corresponding sides, then the triangles are congruent also. So we're going to use this first one, which is called side, side, side congruence, to show that the triangles are congruent. Okay, this is a theorem. Instead of having to write out side, side, side congruence theorem each time, we can use the abbreviation SSS. So once I write this, from now on, you guys are going to know that this means side, side, side. Here's what this states. If 3 sides of one triangle are congruent to 3 sides of another triangle, then the triangles are congruent. So we can use this to prove that 2 triangles are congruent just by focusing on the sides. All right? So here's what you might see as an example. So I've got 2 triangles. I'll call one ABC and the other DEF. If I can show that AB is congruent to DE and BC is congruent to EF, and AC is congruent to DF, okay, or like this, AB is congruent to DE, and BC is congruent to EF, and AC is congruent to DF, like that, then triangle ABC is congruent to triangle DEF. And the reason is side, side, side. All right? So we're going to do an example. We're going to actually do a proof together to prove that 2 triangles are congruent. And so I'm going to show you what to write down, and you're going to need to pause the video and copy this down. And then we will begin our proof. Okay, we should have this copied down. Everything from here down, you need to have copied down. It's going to take a little bit of room here. We are given that PQ is congruent to ST and QR is congruent to RT, or TR, and that R is the midpoint of PS. We want to prove that these two triangles are congruent, and we want to use side, side, side. I want to show that there are three pairs of corresponding congruent sides so that I can prove triangle PQR is congruent to triangle STR. Okay, so I'm going to give you some of these statements, and then I'll give you the reasons in it. What you'll notice on some of these that you do on your assignment, I'll give you all the statements, you just have to match up the reasons. Okay, so the first thing we want to do is we're going to list out each of these statements separately for the given. Now I'll explain why after we get done. So we're going to first state that PQ is congruent to ST, because it's given. And we can state that QR is congruent to RT, because it's given. Now, we've already shown two pairs of congruent corresponding sides. We can mark PQ congruent to ST, and we can mark QR congruent to TR, or RT. So there's two pairs of corresponding congruent sides. I just need a third pair. That's why this other given statement is listed separately. PS. R is the midpoint of PS. Sorry, that should say PS there. And that's given to us. Now, this does not say that two segments are congruent, but it leads me to that fact. If R is the midpoint of PS, that means that these two other segments of the triangles are congruent, because that's what the word midpoint means. Okay, so I can say that PR is congruent to RS by definition of the word midpoint. Okay? Well, that is the third pair of corresponding congruent sides. So we can finish our proof since I've shown three pairs of congruent corresponding sides. Okay? What I like to do when I'm doing these proofs, as soon as I say one of the things that I'm going to need to use, I just make a little note out to the side that that's one pair of congruent corresponding sides, 1S. This is a second pair. Then 3 leads me to 4, which is where I state the third pair of congruent corresponding sides. So I put little S's by these. Once I get all 3 done, then I know I can finish the proof with this statement. Triangle PQR is congruent to triangle STR by side, side, side congruence. Okay? So let's keep moving right along. All right, we have another shortcut explanation here. All right, and that's called side angle side. Now, as soon as I pull these back out, if I were to try and match these up, and I told you that this side was congruent to another side in another triangle, and this one congruent to this one, and I told you that angle was congruent in both of these, the only way to fit this in here is to make it the same as the other side. So what we can do is show that triangles are congruent by using what's called side angle side congruence theorem, or SAS. Okay, so we're going to use SAS. I'm going to explain what that is. If two sides of one triangle are congruent to two sides of another triangle, and the included angles are congruent, then the triangles are congruent. Now we're going to look at what the word included angles means. Okay? Included angles are the angles between the two pairs of congruent sides. Okay, so if this side is congruent to this side, and this side is congruent to this side, and the included angles are congruent, then these triangles have to be the same. Okay? If I call this one triangle A, B, C, and D, E, F. If AB is congruent to DE, and AC is congruent to DF, and now both are using A for one triangle and D for the other. So I want to say and angle A is congruent to angle D. Then triangle ABC is congruent to triangle DEF. Okay? So that is the side-angle-side congruence theorem. The first one we used was side-side-side congruence theorem. Those two theorems are two ways we can prove that triangles are congruent. Okay, we're going to try one more example. I'm going to turn the page, and you're going to have some things to copy down, and then we will work on the proof together. Alright, so this is our second example. Pause the video so you can get this copied down. Don't worry about highlighting anything yet. Just copy down what's written in black. Okay, for this example, make sure you copy it down exactly. I've given you the statements for the proof this time. We're just going to fill in the reasons. Okay, so go ahead and get this copied down. If you need time to pause, go ahead. Alright, so let's take a look at what we're trying to do. We're given this figure. We do have two triangles. Okay, we stick them together to form this rectangle, but these are two triangles. We are given that JM is congruent to NL, so I want to mark those congruent. Okay, you always want to start a proof if they give you congruent information in your given statements. You want to mark the givens in the diagram to match it. Okay, and then we are also told that angle JMN, this angle, is congruent to LNM, this angle. Okay, so there's a pair of congruent angles. And we want to prove that these two triangles are congruent. Now there's some other information I'm going to point out to you as we go through this. But we're going to start with the first given statement. JM is congruent to NL. That is given. And in this lesson, you're going to notice we write out the givens separately each of these times, because that is a pair of congruent sides. That's a side of the triangle, that's its corresponding side in the other triangle, so that's a pair of congruent sides. But this is a pair of congruent angles in the triangles. Angle JMN and LNM are here. That is also given. Those are the only two givens, but then they throw in statement 3. Statement 3, we say that MN is congruent to MN. MN is the same segment for both triangles. Both these triangles share that as a side. We have a reason that tells us any figure, or any segment in this case, is always congruent to itself. This is called the reflexive POC, property of congruence. You might remember that from earlier in the year. Anytime we say that something is itself by congruence, or something is congruent to itself, that's the reflexive property of congruence. Well, that's that third or second pair of congruent sides. Okay, so MN is congruent to itself. So there's another pair of congruent sides. Look what we said. Sides, two sides of one triangle, congruent to two sides of the other triangle, and the included angles. That means the angle formed by these two different pairs of sides. Okay, the angle is included between these two different side lengths. Those are congruent. So we can say the triangle is congruent by side, angle, side. Or sorry, the triangles are congruent by side, angle, side. Okay, we're going to do a lot more examples in class, but this should just get you started. We're also going to be taking some notes on equilateral triangles in class. Sorry, equilateral and isosceles. Okay, because there's some information we need to point out about those two. So that's what we're going to start talking about in class.